All right. Good morning, class. How are you guys? Welcome back again to our lectures after the midterm exams. And I hope it was something that you expected. There was nothing there that we didn't do in the class. So if someone has something to say, we, we have 1 minute. We can have a discussion like 1 minute before other people will join us. If you have anything to say regarding the midterm exam or anything related to this course, you are welcome. So you don't have anything to say, okay? So you guys, you don't have anything, all right? Meaning that the exam was fine. Solving, okay, graphing.
Mr. Ture,
Yes.
I have a question, but how do you put this thing? There was a question, but I forgot it.
Well, try to remember it if you want us to discuss about it. So still you don't remember it?
No.
But how was the exit, the midterm?
It was okay.
It was okay. Should be. All right. So when we are starting a new topic called, if you look at it, the national income determination, it didn't come in the exam. So many people were worried about it. So I set the questions even before that topic. So it didn't come in the midterm. But every topic we have seen, somehow, whether midterm or final, you will assess on it. And also what we have done in midterm can come again. It doesn't matter. Because finally, that's the purpose of final. You bring everything on board. So we are starting a new topic today. It's nonlinear equations. We have a lot of different non-linear equation, but our focus for this class will be on quadratic. That's the simplest non-linear equation. We will look at quadratic equation. So our focus will be on quadratic equation. And we are going to look at how we can solve these quadratic equations. And we are going to see how we can graph them, looking at some features, 2 or 3 things that we have to compute, so we're able to graph it. So once we know the mathematics of nonlinear equation, especially quadratics, we will want to apply it to microeconomics. So we will apply it to demand. We have seen demand and supply, but we have seen it in a linear model. Now we are going to look at it at nonlinear model. And when we say nonlinear, we are talking here quadratic equation. So then we will also look at in the business world where we will have revenue, application of quadratic equation in revenue, cost, and profit. So today the goal is to cover this. I don't know whether time will permit us. If it doesn't permit us, then we continue with it where we will stop today in the next class. So first of all, the nonlinear equation that we will look here, it will be what? Quadratic equation. So obviously, once we finish this, then that's the time we will start calculus. By now, you will have all the foundation calculus. Some people, you will hear topic like differentiation and others. Hopefully, time will permit us before the exams. So we can do light introduction to this and go as far as time permits us before the final trimester exams. So it is only this that is between us with calculus, and let's hope that we will cover this quickly. Then we will start calculus. But now let's focus on quadratic equation. So quadratic equation is a nonlinear equation with the highest power of 2 within the equation. So the standard format of quadratic equation is like this. So normally quadratic equation is represented as ax with power of 2 plus bx plus c equals to 0. So this is a standard quadratic equation. So why do they call it quadratic? Obviously, it's because of the highest power there. The highest power there is what? It's 2. So because of that, we call it quadratic equation. The highest power in quadratic equation is 2. So here, A, B, and C, if you looked at them, they are parameters, but A and B, they are what? They are coefficient. You understand? So A and B, they are coefficient. And C is what? A constant. So coefficient and constant together in mathematics, we call them parameters. We call them parameters. So we see that, and the variable here is what? Is x. So the first x, this is the quadratic component. Because it's having 2. Then you have the linear component here, and you have the constant. So our goal here is one, how do we solve this? We want to know how do we solve this kind of equation. So how do we solve this? And another thing that we want to know about this equation, how do we graph it? So these are the two questions that we will pursue today. We will be given a quadratic equation. Any quadratic equation that you see, it will be in this form: ax plus bx plus c equals to 0. So normally a, b, and c, these are in general form. They are represented by numbers. For example, you can have a quadratic equation like this: 2x raised to the power of 2 plus x plus 6. You can have it like this. So here, the 2 here is the a. And this x, always we know that a variable, there is a constant always attached to it. So there's a 1 here. So the b here is 1, and 6 is the c. So this is it. So this is a general form, but this one is a specific form. So if we have this kind of quadratic equation, two things should come to our mind. How do we solve it? And how can we graph it? So we will look at the mathematics of quadratic equation. Once we understand them, then we will apply them in real life. And when I say real life, we will apply them to demand and supply. Then we also apply to revenue, cost, and profit. But before we do the application, that is 3 and 4, we need to understand how do we solve it and how do we graph it. So the first part is solving quadratic equation. So how do we solve quadratic equation? There are two methods. We can use it. We can use factorization, which most of you people, I'm sure you are familiar with it. We can use quadratic formula. That's another way. Quadratic formula. Or we can use factorization. So this quadratic formula, it came as a result of completing the square. We are not going to go into detail to see how we derive completing the square or quadratic formula. So this is the first method. This is the second method. So for quadratic formula, always it works, you understand? But for factorization, some quadratic equations, factorization, you cannot use it, it doesn't work. So when you have an equation like this, plus bx plus c equals to 0. So to solve it, you can either use this quadratic formula or you use factorization. But for factorization, sometimes it doesn't work. But for quadratic formula, it always works. So it's important we have these two tools in our box to make sure that we can apply one of them, especially quadratic formula. So let's look at what do we mean by quadratic formula. So if you want to say solving this equation, it means we want to know what is the value of x. So to use the quadratic formula, the formula states that x will be equals to minus b plus or minus in square root b raised to the power of 2 minus, I always put this in bracket, 4ac. So to know that the minus sign is affecting everything here, all over 2a or 2 times a. So this is the quadratic formula that we use to solve a quadratic equation. So this is something everyone should know. It will not be given to you, you should memorize it or find a way to remember it. So what do we mean by b AC. So if you look at A here, normally let's even have a specific quadratic equation. Let's say that the quadratic equation is x minus x raised to the power of 2 plus 2x minus 3. So here, to use this formula, you must know what is A, you must know what is B, you must know what is C. So if this quadratic equation is given to you and they ask you to solve it, your A is the coefficient of the quadratic term, which is -1. Even though it's not stated here, if a variable is standing alone, know that there's a 1 attached to it. So A will be -1, that is this one. B will be 2, and C will be -3. So you just use this and substitute this, you will find it. So when we talked about factorization, it's a whole different thing. So the best way to learn this is for us to take 1 or 2 examples, or even 3 examples, and try to solve those quadratic equations using quadratic formula, as well as factorization. Let's take our first example. For example, let's solve the quadratic equation. So the equation is what? X raised to the power of 2 minus 4x plus 4 equals to 0. So they ask us to solve this. First, when you are asked to solve this, then meaning that they are asking us to find the value of x. So we have our solution. First, we know that first, let's use quadratic formula. Then we will also, then we use factorization. Whichever method you use, you should arrive at the same answer. So if we want to use the quadratic formula, which state that x equals to minus b plus or minus in square root b square minus 4ac all over 2 times a. So if you look at this equation here, we know that our a is the coefficient that is attached to here. So we need to find what? We need to know what is our a. We need to know what is our b. We need to know what is our c. So once we know, then we can substitute it in this quadratic equation. So always a is the coefficient that is attached to here. So in the quadratic term of the equation. So the quadratic term is the variable with the 2 as the power. So if the variable is standing alone without no number attached to it, we can always assume that it's 1. But if there's a negative here, it will be -1. So our a will be 1. B is the coefficient that is attached to the here. So which is what? -4. Which is -4. Then our C is the constant term, which is 4. So now that we have these values, so what we will do is substitute it here to this quadratic equation. So if we do that, what we will have, it will be x equals to minus, we said that b, and we said b is what? -4. Then we have our plus or minus. We have this. So b square means -4 times -4 minus 4ac. 4 times A, and we know that our A is 1, times C, and we know that our C is what? 4. We have this. So at the end of the day, all over 2 times A, and our A is 1. So we will have X equals to 4 minus minus will give you 4, positive 4, plus or minus. So this times this will give you what? 16 minus 4 times 1, that is 4. 4 times 4, 16. Then with this minus, it will give you minus 16. All over 2. So what we will have here, we have this 4, our plus or minus 0 all over 2. So at the end of the day, what we will have, it will be X equals to 4 plus or minus, the square root of 0 is 0, we know that, then over 2. So here, this plus and minus, this is where you will break it out. So you will introduce a variable called x1, which will take that, the positive side, will be 4 plus 0 over 2. Or you can introduce another one, x2, then x2, that will take the minus, 4 minus 0 over 2. So this will be what? 4 over 2. And this one also will be 4 over 2. So here will be 2, and here will be 2. So in this case, our x1 and x2 are the same. Then equals to 2. We have this. So the solution to this is what? X equals to 2. So this is what we mean by solving a quadratic equation. So we use quadratic formula, but now let's use factorization and see. So the equation is what? This is the equation given to us. They ask us to solve it. Minus 4x plus 4 equals to 0. So the question that is asked is to solve this. And what does that mean? Is to find the value of x. We want to know the value of x. So to use factorization, first thing that you do is to focus on this quadratic term and the constant term. So what you have to do here, find two variables. When you multiply, you will have x raised to the power of 2. And obviously those two numbers, those two variables are x times x. X times x will give you x raised to the power of 2. It should give you this. So once you do that also, focus on two numbers. When you multiply them, it will give you plus 4, this one. It will give you plus 4. So we know that minus 2 times minus 2 will give us positive 4, that is plus 4. But equally also, we can say 2 times 2, that can also give us 4. Equally also, 4 times 1 can give us 4. Not so. Or minus 4 times minus 1 can give us 4 as well. But which of these should you take? So that's the question. Here it's easier. We only have two factors for x raised to the power of 2. That is x times x squared. But when you come to this 4, there are many factors. When you multiply, they can give you 4. Minus 2 times minus 1 could give you 4. 2 times 2 could give you 4. 4 times 1 could give you 4, or minus 4 times minus 1 could give you 4. But when you are choosing the right one, you choose in such a way that when you choose, for example, this is the correct one. And I will tell you why. So let's assume that we choose minus 2 times minus 2. So we have here minus 2 times minus 2. Minus 2 times minus 2 will give you plus 4. So the number that you are choosing, you should choose in such a way that when you cross multiply this and this, it should be able to give you what? Minus 4x. So let's cross multiply this. So the x times minus 2x will give you minus 2x. This times this will give you minus 2x. This times this will give you minus 2x. So minus 2x minus 2x will give you minus 4x. So then it's only minus 2 times minus 2. When we choose them and cross multiply with these ones, then we'll have minus 4x. So obviously minus 2 times minus 2 is the correct one. If you choose any other number than minus 2 times minus 2, you won't be able to get the middle term. That is the linear component, that is minus 4x. So this is how you factorize. There might be other ways as well, but this is the well-known method, and I think it's easy as well. So there will be no restriction which method, but it's important you know both of them. You can use the quadratic if you find that easier, or you can use factorization if you find that one easier. It depends on you. So at the end of the day, we will have x. These are the two factors we will take and find out. So what, after finding this, what you have to do next is to take this and this, and you multiply them and equate it to 0. So it will be x minus 2 multiplied by, this is x minus this 2, then this x also minus 2, x minus 2, this is 2, then equals to 0. So let's go to next slide so that we had this and we had this. So what you will do, you just choose this and you choose this. You multiply this by this and you equate it to 0. So it will be x minus 2 multiplied by the second one, x minus 2 equals to 0. So it will be x, this first one, minus 2. We can call this x1 now. We are separating them, equals to 0. Or this x minus 2 equals to 0. We call this x2. x2 minus 2 equals to 0. Then x1 equals to 2. Or x2 equals to 2. So both x1 is the same as x2, and both of them are equals to 2. So this is how you factorize a quadratic equation to find the solution to it. So if you looked at it, we have 2 here under factorization. So if you go to the quadratic also, we have 2 as well. So at the end of the day, you will have the same answer, irrespective of which method you use. Okay, they said we have 10 more minutes, but I will always log back as we normally do. So now these are the 2 ways you can solve quadratic equation. These are things that I'm sure we have seen in high school, so I will not waste much of my time. So, but another quadratic equation I want us to see is this. Sometimes, remember, we are trying to solve quadratic equations. Sometimes quadratic equation, they don't have a solution. It can have one solution, like the case for this one is one solution. When do we have one solution? Is when x1 is equals to x2. So we can also have many solutions. That is when x1 is not equals to x2. Or we could not have any solution. There will be no solution. So there could be one solution, that is, some people will call it the root. In fact, the solution, some people call it the root of the equation. Some people call it root of the equation. So you can have one root, two root, or no roots. So quadratic equation, there might be solution, there might not be any solution. And if there's a solution, the solution might be one solution or two solutions. So please, let's take note of that. So let's look at this situation like example 2. We have example 2. So this is given to us 3x raised to the power of 2 minus 5x plus 6 equals to 0. And they ask us to solve this. That is, they want us to find the solution, that is the value of x, or to find the roots of the equation. So normally what we do to find the solution, you first state your quadratic equation, quadratic formula rather. You state your quadratic formula, which equals to minus b plus or minus b square minus 4ac and square all over 2 times a. So first we need to find what our a is. We need to find out what is our b, and we need to find out what is our c. So not a always, as I told you, a is the coefficient that is attached to the linear component. This is our linear component. So the number that is attached to it is always the a, and in this case is 3. And the b is the coefficient that is attached to the linear component, which is here in this case is what? Is 5, minus 5 rather. It's not 5, but minus 5. So the c is the constant there, which is this plus 6. So we can just write only 6. So once you know this, then it's just for you to substitute it here.
Yes.
This idiot. Yes. See what you did. What did I do?
Can we mute?
Please, please.
You know, maybe this will be our last online lectures. Calculus is something that is very tedious to lecture, and I need. It's even hard because there will be
online.
Let me finish, please. We have a lot of visualization, so this might be, understand. Once we start calculus, we might go back to the campus. We all know why we are here.
Sure.
You know, if you are not interested, you can easily log off. But we should have respect for our colleagues. It's important. We have been talking about the same issue since I don't know when. So most likely the how to call it, if you time permit us, we start calculus, classes will be conducted physically. It's easy, you know, mute your mic and talk. So once we finish this nonlinear, we start the calculus. We are going back to the most probably. I will analyze. You know, we will have the physical class because it won't take us 2 or 3 classes. Then we have our finals. Okay. So let's. Where are we? Yeah. Let's continue. So now what you need to do is to substitute this back to the equation. And yeah, so you can also use factorization, but the problem with factorization, sometimes it doesn't work. So that's why, you know, most people prefer the quadratic equation. So what we are going to do now, we are going to substitute this into the quadratic formula and try to find our root of the equation, or to find the value of x. So we have x here, x equals to minus, b is what? B is minus 5. Plus or minus. Then our b, we know it is minus 5. Minus 4 times a, which is 3. This is 4 times a, which is 4 times 3, then times c, and we said our c is what? 6. All over 2 times a. So 2 times a, and our a is what? 3. So once we do this, let's go to the next slide before the time goes off. It will give us something like this: 5 plus or minus. Let's be quick in taking the notes. We have only 2 minutes before it goes off. 25 minus 72 all over 6. So this will give us what? 5 plus, this will be minus 47 all over 6. So at the end of the day, our x will be 5 plus or minus 47 all over 6. So can you take your calculator and just punch the square root of minus 47 and see what it will give you? If you have calculator there, anyone punch, or all of you, if you have, anyone who is having
math error.
Yes, it will give you math
It's
error.
math error.
Exactly. So still now mathematicians are battling with to come up with solution to this. Of course, there are way out of this. You can root complex numbers or imaginary numbers trying to solve these issues, but that is beyond this class. So once you come to this, you have this, then you can just decide there is what? There is no solution. So the quadratic equation has no solution. Or let's just say no solution in short. The quadratic equation has no solution. So once this becomes a negative, or the term that is here, it becomes negative, you can't find solution for it. So you can just conclude that there is no solution. So you will see that the term, this term that is inside here, is very, very important to determine whether the quadratic equation has a solution or not. So let's look at the term. The term inside there is what? B square minus 4AC. And I don't know, is there anyone who know the name of this B square minus 4AC?
I think it's almighty formula.
Yes, no. The formula itself, people used to call it that. The word, everything here is called, they used to call it in high school almighty formula.